Welcome to this tutorial on creating a 3D exploration game using Java. In this series, we will cover everything from setting up your development environment to coding your game mechanics and graphics. Before we dive in, make sure you have Java Development Kit, JDK, and an IDE like IntelliJ IDEA or Eclipse installed. Now, let's get started with setting up our project structure. Create a new Java project in your IDE and name it 3D Exploration Game. Inside the project, create the following directory structure: src/com.example.game, main, model, controller, view. This structure will help you organize your game code effectively. Next, let's add the libraries we need for 3D rendering. We will use the lightweight Java Game Library, LWJGL. You can download it from its official website and configure it in your project. Now let's write the main class for our game. This class will create a window and start the game loop. Let's create a new class named Game. In this code, we have set up the display for our game window, and we have a simple game loop that keeps running until the window is closed. However, right now, it doesn't do much yet. Let's add some 3D rendering capabilities next. To set up 3D rendering, you will need to initialize OpenGL. Add the following initialization method to your game class. Call the init_OpenGL method in your start method just after creating the display. Your updated start method should look like this. Now, let's create a simple 3D cube to represent our player or first object in the game. Create a new method called renderCube. We will define vertices and draw the cube using OpenGL. Now, we need to call renderCube inside our game loop right before the display.update method to see the cube on the screen. Update your game loop like this. Run your program. You should see a colorful 3D cube spinning in your game window. This is a great first step into 3D graphics. Now, let's move on to player movement. We can achieve player movement through keyboard input. To do this, let's modify our game class to capture key presses. We will store the player's position and update it based on the input. We also need to update the camera position to follow the player's movement. Adjust the renderCube method to reflect the player's new position. Call the handleInput method in your game loop before rendering the cube. Your updated loop should look like this. Test your game now. You should be able to move the cube around using the arrow keys. This creates a basic form of player control, which is crucial for our exploration game. Next up, let's create some terrain for our player to explore. We will generate a simple plane to represent the ground. Add the following method to your game class. Call the renderGround method inside your game loop before rendering the cube, like this. After running the game again, you'll see a simple ground under your cube. This gives a sense of space for our exploration game. Next, we can implement some basic textures onto our terrain. Let's load a texture for our ground. First, you'll need to create a resource folder in your project structure and place your texture image file inside it. For this tutorial, let's assume we have a file named grass.png. Now, we will write a method to load our texture. Add the following code to your game class. In this method, we will use an external library called stbimage to decode our image files. Make sure to add the required dependencies to your project. We'll use the texture during our renderGround method. Don't forget to call the init method inside your start method after OpenGL initialization. Update it like this. Next, modify the renderGround method to bind the grass texture. You can do this by adding the following lines. This will allow our ground to show the grass texture upon rendering. Run your program and marvel at your textured terrain now. As you may have noticed, our game is coming together quite nicely. Now let's implement some simple collectible items. In our exploration game, these items can increase the player's score. First, create a new class named collectible item in the model package. This class will hold the coordinates and status of our collectible item. Next, we'll create a rendering method within the class to display the item in the game world. Next, create a list to hold our collectible items in the game class. We will initialize this list when the game starts. Call the initCollectibles method inside your init method to populate the collectible items. Now, update the render method to draw all collectible items in your game loop. Run the game, and you should now see collectible items in your world. Next, we will implement a simple collision detection system so players can collect these items. To detect collisions, Create a new method in the game class that checks if the player's coordinates overlap with any collectible's coordinates. Check for collisions in the game loop as well, above the render methods. Call check collisions before rendering the collectibles. Try collecting the items. Adjust your player's position to overlap with the items, and you'll notice that they disappear, showcasing that they have been collected. This adds depth to your exploration game. As a final touch for our exploration game, we can implement a basic scoring system. We will keep track of a score variable and update it each time an item is collected. In the collect method of collectible item, call the update score method when the item is collected. This ties our score increase to the collectibles. Lastly, let's display the score on our game screen. Use this code snippet to render the score using the OpenGL text rendering tools. Call the render score method inside the game loop after rendering items. So your game loop will now look like this. Run your game once more. Now you should see the score displayed at the top left corner, increasing as you collect the objects. You have successfully built the foundation for a 3D exploration game using Java. In summary, we covered how to set up a 3D environment, create player-controlled movement, implement collectible items, and display a score. Experiment with the code to add features like different terrains, more collectible types, or even enemies to challenge players. Thank you for watching this tutorial. If you found it helpful, please like and subscribe for more Java programming content. Let me know what you would like to learn next in the comments below.